Welcome back. We're going to look at acid nomenclature. So first of all, an acid is a substance that can produce H plus ions when mixed with water. Therefore, most compounds involving hydrogen and another ion are considered to be acids. If they begin with an H, they're considered an acid, except in the case of H2O. So we're going to look at three different types here: binary, polyatomic ending in Aight, and polyatomic ending in Aight. So it has to do with the element elements that are combined with hydrogen. So if we look at binary acids, binary meaning two, H and only one other element. Of course, the other elements, single elements, if you notice earlier, those nonmetals end with the ending "ide." So if you look at the rule here, these always start with the prefix hydro. So the prefix hydro is used with all of these in acid naming. So they begin with hydro, attach the second element name ending with "ic," and then the word acid. So here we have hydrogen and the fluoride ion. So the "ide" becomes "ic." So we think of it as "ide" becomes "ic." So the fluoride becomes "ic," and also the prefix hydro. So HF would be hydrofluoric acid. Okay? Hydrofluoric. So it was fluoride, the "ide" becomes "ic," and the word prefix hydro. H2S. Now the reason why we have two hydrogens there is because sulfide is 2 negative. Hydrogen's 1 plus, so of course we need two hydrogens to balance one sulfide. So again, "ide" becomes "ic," so sulfic, we'd think it would be hydrosulfic acid, but actually this is going to be one of the exceptions to the rule, in that it is actually hydrosulfuric, so there's an extra UR added in there. So instead of sulfic, it's sulfuric. Okay, so binary acids, hydro and "ide" becomes "ic." If we look at polyatomic acids that end in "ate," so for example the sulfate ion, the SO4, or the nitrate ion, NO3. If we take a look here, the polyatomic ion is named first, dropping the "ate" and adding the "ic." So we can think of it as going from "ate" to "ic." And notice there's no hydro. Hydro is only used in binary acids when there's H and only one other element. If there's a group of nonmetals, it's not used. So sulfate, sulfic. Now again, this is going to be an exception. So it's actually if we follow the rule blindly, it's sulfic, but actually we add an extra U and an R there, sulfuric acid. And I'll have some of these exceptions labeled on the next page. You'll have access to them, so you'll always be able to figure that out. The NO3 group is the nitrate. So nitrate becomes nitric, so nitric acid. Okay, so 8 becomes "ic," with the exception of a couple of rules here. Lastly, polyatomic acids ending in "ite." These compounds involving hydrogen and the polyatomic ending in "ite" drop the "ite" and use the word "us." So "ite" to "us." So we can envision that to be. So SO3, see, it's very similar here. These ones are both very similar, except one less oxygen. And if you look at your ion charge tables, you'll see that SO3 is sulfite, and NO2 is nitrite as opposed to nitrate. So sulfite becomes sulfus, but with these sulfuric ones, there's an extra U and an R added into there, I guess just to make it sound better. So once again, I'll have these labeled on the next page. But for the most part, we can follow the rule. Nitrite becomes nitrous acid, as you can see there. Okay, so 3 basic rules for acid naming. So when you do the flip side here, you can use those rules there to name those. So binary acids, etc. Looking over here, write the formula for these acids, etc. Now at the very bottom I have those acid exceptions, so putting all of them down. H3PO4 should be phosphic, but it's actually phosphoric. H3PO3, phosphus, but it actually is phosphorus acid. And the ones that we looked at already, sulfic acid should be sulfuric, sulfus should be sulfurous acid, and hydrosulfic should be hydrosulfuric acid. Okay, so those are some of the exceptions. So you can try these questions up here, 1 to 12, and see how you make out. Okay, I'll see you again.